Now for our last session, we have a special plenary session that's going to be perfect to set the tone for our welcome reception. And to introduce our speaker is AGS counselor, and as of yesterday, he was the president of the Radiant Group. I don't know what his title is today, Mr. Al DiLeonardo.
Thank you, John. Glad to be here today. I was asked to intro Dr. Scott, and I'll do that in just a minute. I'm Al DiLeonardo, former president of the Radiant Group, founder of Human Geo. We're longtime sponsors of AGS, proud to be a sponsor, and now part of DigitalGlobe. We know it's late, we know we're before cocktails, but you're going to get a great presentation. And I was asked by a few key members of the council to lighten up the mood here before Walter gets on stage. So before I go in his bio, I'm going to tell something that happened today, pretty embarrassing. So I've only met Walter maybe once or twice before today, years ago. And so I got the task today and I'm speaking as a council member right now, not as a DigitalGlobe employee for a minute. And so I had to do a pre-brief with him, and he doesn't even know this. But as soon as I got here at noon, I bent down and I ripped my pants by 12 inches. And everybody who saw me back there, right, in the middle, down in the back. And I'm gonna just say it this way. So I was gonna go get new pants, didn't have enough time at that moment. He comes out, and I'm literally briefing the CTO of DigitalGlobe for the first time with my ass hanging out. Totally true story. Okay, so let me get on with it. Dr. Scott founded DigitalGlobe in 1992 as Worldview Imaging Corporation, which was the first company to receive a high-resolution commercial remote sensing license from the U.S. government. This company eventually, through changes, became DigitalGlobe. Dr. Scott holds a bachelor in mathematics from Harvard and a master's in science from the University of California at Berkeley. He spent time at Livermore National Laboratory. He's a member of the National Research Council's Committee on Earth Sciences and Applications from Space, and a member of the board of directors of the Open Geospatial Consortium. I'm glad to be part of DigitalGlobe and now as Radiant Group DigitalGlobe today, and welcome Dr. Scott, please. Thank you.
Appreciate it. Great. All right. The topic is remote sensing and sustainability, and I'll start with what I mean by remote sensing and go back a little bit in time. During the Cold War, satellites, super secret satellites, were used to enable the United States to act on the basis of facts as opposed to on the basis of fears. But it was something that was limited to a very small population, really just a few people in a very small community at the time. Remote sensing really didn't make its way into widespread awareness until the 1980s, when those of you who were alive back then may remember the Chernobyl disaster, and Spot, the French satellite, was able to show people something that was happening half a world away in a place that you really couldn't get to at the time, the Soviet Union. Roll the clock forward to the emergence of the modern industry, and there were a number of things that happened in the early 1990s. The first was that satellite technology had undergone what in many respects was a revolution. It was actually what planted the seeds for what you hear today as the new space revolution. It actually goes back to the late 1980s. There was Moore's Law, which made it possible for imagery to make its way to your desktop. What previously were almost glass teletypes could now display pictures. It was also the beginning of the internet as we know it today. The third was the end of the Cold War, and that changed a world that was a very static, bipolar world into one where there was a lot of uncertainty. It led to some policy changes, one of which was the foundation of, or I should say the passage of the Land Remote Sensing Policy Act, which allowed for private firms to get into the high-resolution imaging business. And lastly, I had some time on my hands because I broke my foot playing paintball. So I wrote a business plan. Now, you look at where remote sensing is today, and it's pretty ubiquitous. If you've ever looked at a satellite image on a mobile device or a web mapping platform, probably came from DigitalGlobe. You see it on your handheld devices. And you're starting to see not just satellites, but also other forms of remote sensors like drones making their way into applications like, for example, precision agriculture. Interesting tie-in to an earlier talk. One of the things precision agriculture allows for farmers to do is dramatically reduce the amount of fertilizer and other crop inputs so that they're adding only what they need as opposed to adding so much that it ends up running off and creating algal blooms that create the effects you heard about earlier. And also managing infrastructure like solar panels in cities. Now, the thing I want everybody to wrap their heads around is that it's a really big planet. And what I want you to do is just look around this room, and this is the sort of space that as humans we're able to readily grasp in a level of detail that we're comfortable with. You know, you look around this room, you kind of get the sense of how many people are in the room, you get the sense of the furniture in the room, the lights and so forth. Not a lot of plants, but if we were outside, we'd see plants. But now imagine an area the size of the campus. It's starting to get a little bit bigger. Those of us who visited here just today probably don't have much of a mental map of this campus at all. And now as we start moving further and further away to city or state or continent or even planet, looks pretty small, but that has a planet's worth of the level of detail that exists inside this room, just replicated a few gazillion times. And the only way to really get around that is with the sort of technology that remote sensing brings. And we are at a pivotal point today, right in this time frame, not this moment in time, where it's actually possible to deal with that flood of data. And I'm going to talk about some ways in which that can be done and how it can be applied to sustainability problems. So, remote sensing is really about filling in the white space in our maps. You've got a map here on the left. This is a map of a portion of Africa that it looks like there's not a lot going on there. There's a road and an intersection. But in fact, there's a lot more there. And this particular road in this particular part of Africa was right in the middle of the Ebola outbreak. And in the space of 24 hours, the Humanitarian OpenStreetMap team created what you see on the right, which was a massive densification of what previously was a map with a whole heck of a lot of white space. And that was only possible because remote sensing provided that base context to enable the mapping. Now, remote sensing does more than just see what the surface features are. Some of you may be aware of a technology called interferometric SAR that allows you to measure very small changes in the surface, which, among other things, can tell you about variation in the water table. This is the variation over the course of a season of the water table over the Los Angeles basin. So it's not just good at seeing what's on the ground, but even seeing things that are below the ground. Now, the industry's been evolving. If you look at the horizontal axis, it's giving you a sense of resolution. The vertical axis is the temporal resolution, or how frequently it's possible to make an observation. And then the size of the dot is the area is proportional to the data volume. And so if you go look back at 1986 when Spot was out there, not a lot of data volume, not a lot of frequency of refresh, and not very good resolution. But now as we advance through to the introduction of some new systems, DigitalGlobe, and the commercial radar systems, you're beginning to see not only are there data volumes that are increasing, but there are also different phenomenologies that are out there. By the way, one of the things I want to call attention to, you see the radar systems, they look like really tiny dots. That's because the actual data volume is not that much. You get a lot more data volume from electro-optical systems by far than you get from radar systems. But what radar systems let you do, unlike electro-optical, is see through the clouds. Or they also allow you to do things at multiple resolutions. And when I spend some time a little later, I'm going to talk about an example where that's actually quite helpful. Roll the clock forward a little bit further to the end of this year with the launch of our most recent satellite, WorldView 4. And 2020, where now you have some of the emerging players in the remote sensing industry adding their capabilities. And what you're beginning to see are clusters that apply to different sets of use cases. One of them is a large area primarily focused on change detection, but one that offers truly planetary coverage. Another is high resolution, high accuracy. So once you've seen something that might be a change, you can go figure out what it is. And a third cluster that is much higher frequency, intraday revisit, that allows you to monitor things with frequencies as fast as once every 20 minutes. So we'll see how some of these apply in a moment. Now, that's a lot of data. And how are you going to analyze that quantity of data? It's one thing to talk about remote sensing on the desktop, and we've all seen examples of that. But remember, I said it's a big planet. And if we're really talking about sustainability, it's not about what you can do on a desktop. It's about what you can do on a country or a continent scale. So I want to give you just one visual, and that is how much data we're talking about. So if 1 byte is, say, the size of a grain of rice, how about just what DigitalGlobe has collected, which is about 100 petabytes worth of data? Is it maybe a container ship full of rice? How about 200,000 container ships, which is 40 times the world fleet and enough to circle more than the Earth once around? That's a lot of data. It's data boulders from space that fall out of space and destroy IT departments, which is not a good thing. Now, to deal with that, we built an IT department. We built a data infrastructure, but the problem was our data was sitting inside jail. We had a data IT infrastructure, but in order for somebody to actually do anything with it, they'd need to build the same thing. Not very easy to find many people outside of Google and Facebook that had infrastructures like that. So we leveraged 3 trends. One of them is elastic cloud computing. Amazon Web Services means that instead of data being in jail, it's in a place where everybody can get access to it. The second is deep learning. Just because you have access to the data, there just aren't enough people to look at all the data that we're talking about. It's well beyond the scale of humans being able to look at every picture. So you need to apply a computer technology like this form of artificial intelligence that's gotten to the point where it's good enough to be able to recognize in imagery things that previously only humans were able to recognize. But now, machines are stupid. They have to be trained, and one of the ways of training them is using crowdsourcing, whether it's crowdsourcing to map, like what we did for the Ebola outbreak, or crowdsourcing to identify training data sets to feed into the machine so that the machine is then capable of doing that at scale. All right, so let's give you a few examples. And these are examples of where we're not just talking about something on a desktop, we're talking about something that is of a continent scale. First one is, let's say that you are an insurance company and you need to write a property, a policy for a property. You want to know things like how big is the building, how many stories, what's the roof made out of, how, is it a peaked roof or is it a flat roof, are there trees nearby, solar panels, swimming pools, and so forth. You might send people out with clipboards to do that, which is expensive, or you might call the homeowner and ask, which is sometimes inaccurate. And if you want to do that on a continent the size of Australia with about 13 million dwellings, it's a daunting problem. And yet we're able to apply those 3 technologies I talked about, cloud computing, machine learning, and crowdsourcing, to create roof types using shortwave infrared to tell us what the roof is made out of, and actually building dozens of spatially aligned data layers, whether it's the roof outlines, planning zones, land use land cover, solar panel presence, swimming pools, tree heights, all of that registered into a common data set, and do that at a scale of an entire continent. So as I give you some sustainability examples in the future, I want you to keep in mind this sort of power is now applicable across the entire planet instead of the sort of boutique examples that we've all been familiar with in the past. Facebook. How many people know Facebook? They're interested in connecting the world. But in order to do that, they need to know where people live. So Facebook has been applying the same sort of technology to converting satellite imagery into maps of where people live and estimates of how many people live there. Now, in order for machine learning to actually do its thing, the computers don't develop the algorithms themselves. People do that. And they do that for specific applications, whether it's finding buildings or finding ships or tracking herds of elephants, which people have actually done. And one of the ways of getting lots of people to do that is to put data out in the open and encourage large numbers of researchers to develop the data. That happened with ImageNet, which some of you may be aware of. That was for recognition of just ordinary photos, faces and the like. We're doing the same thing. We're doing that with In-Q-Tel, with NVIDIA, with Amazon Web Services, and with NGA, with the SpaceNet Data Challenge, putting open data, making it available in the Amazon cloud, and running a series of competitions to encourage developers to develop applications, like, for example, on some of the sustainability examples that I'll be describing later. We launched it this past summer, and the first set of competitions are live. And we've already had, I think at last count, well over 500 developers who've signed up and are already starting to develop applications. The kinds of data sets that I'm talking about are, like, for example, Rio de Janeiro. This particular one has satellite imagery along with building footprints, but more to come, more cities, and more points of interest. And as you start thinking about some of the sustainability examples, like smart cities, this is the sort of data that can feed into the development of a wide range of applications. And it's out there for developers to tie into and go to town. So now let's talk about some specific examples for sustainability. Just to set the stage, there are 17 sustainability goals, sustainable development goals, and remote sensing can address 11 out of those. Let's start with an example some of you may have come across. How many people know the Jane Goodall Institute? Jane Goodall does tremendous work with conservation of chimpanzees. And one of the problems that the chimpanzees were facing was persistent destruction of their habitat by villagers living in the area who would cut down trees for a variety of purposes, resulting in removal of places where the chimpanzees lived, as well as increasing runoff, reducing the availability of water in streams. So they used remote sensing to show the villagers what was happening and then provide them with tools for changing their behavior, as well as driving reforestation campaigns. So this is the result. So it was a pretty massive change in the amount of forest habitat. And you can see here, a little bit hard to see, but the black was completely deforested. The green is healthy vegetation. And from 2005 to 2014, a dramatic improvement in the size of the habitat, total area of the habitat for the chimpanzees. And now imagine what I talked about earlier, applying machine learning, crowdsourcing, public clouds, scaling this up to the entire continent of Africa or the entire planet. How about tracking the impact of drought, Lake Shasta? Pretty dramatic shift over a period of a few years. Or responding. Part of sustainability is not just about understanding what happened, but doing something about it and providing a measure of resiliency in the event that something bad does happen. Many of you may be aware of, maybe even were involved in the flooding that occurred late last year in the middle of the United States. So we collected imagery over a period of a couple of weeks, and within typically 72 hours or less, used the TomNod platform for crowdsourcing to identify areas that were damaged, blocked roads and the like, and providing that data to the emergency personnel so that they were able to act on the basis of current knowledge as opposed to having to guess where they needed to go. It's also about helping plan for the future, like, for example, how one might deal with rising sea levels or storm surge in parts of the world that are the most likely to be affected. And here's an example of just modeling the impact of rising sea levels or storm surge in Grenada. Now, we've all heard about smart cities, and what I think most of us think about with smart cities is parking meters that talk to the internet, or air conditioners or thermostats that talk to the internet. Of course, the downside is that those can all be hacked. What about trees? Trees don't talk to the internet. And yet we have examples of places like where I live, in the city of Boulder, where we worry a lot about the change in the urban tree canopy, because the urban tree canopy is an important part of living in an environment like Boulder. It provides us with shade, it improves the quality of life, it helps with our heating bills, because when you have shade, you don't have to worry about as much both heat loss or heat gain, depending on the season. And problem in Boulder is that you have issues with both urbanization and also the invasion of trees that are not native to the area that tend to choke off the ability to reforest with native species. So working with the Rockefeller Foundation, we used satellite remote sensing at the scale of Boulder, the plan being then to take this to a much larger scale, to characterize the trees in the buildings, monitor the changes over time, resulting in this sort of a map. And you can see this is the beginning of a foundation that you can use for a smart city. All right, now I want to talk about another topic that actually ties in with several of the earlier discussions, IUU fishing, illegal fishing. Now it's a fairly complex problem. The simple version is too many people taking too many fish, and that has some obvious negative consequences. It's certainly worsened by economic insecurity, and the downside is when you have too many people taking too many fish, you end up with too few fish on the back end, which is something that ultimately ends up hurting the people living in those areas, not to mention the loss of fish. So what can satellite remote sensing do, or remote sensing writ large, to address that? Well, you can combine AIS data, which tells you where ships are, with satellite imagery, both electro-optical and radar, and modeling tools to provide a view that identifies where fishing is likely to take place, what ships are in the area, what things that look like ships that didn't say that they were ships are in the area as well, and feed that into local authorities to help them better enforce their own fishing areas. And remember that chart that I showed you about the explosion of remote sensing data? And remember I talked about the three categories of remote sensing data, the large area, the high frequency revisit, and the high resolution. We think about how all three of those can combine to monitor a large area, and then once you've identified something that might be of interest, zoom in and take a closer look and potentially monitor it for current activity. Well, I'm going to give you a closing example that is not about fish directly. Fish are part of the story, but it's about people who are affected by illegal fishing. Now, there are about 30 million people in the world that are still enslaved. It's not something we tend to be very much aware of here in the West, but we were approached about a year ago by a reporter, Martha Mendoza from the Associated Press, who was describing to us the situation in Southeast Asia where many men would be recruited with the promise of employment, and they would be effectively captive as slaves for years or decades in awful conditions, kept in cages when they were not on ship. And this was something that was known, but nobody could prove the link between the slave fishing boats and the commercial fishing industry. So they came to DigitalGlobe and said, what could we do? Well, the problem was it's a big ocean, a lot of white space. And we were able to search that area and identify this shot, which was a commercial fishing boat with 2 slave fishing boats tied up to it, with enough detail that the authorities could act with confidence to be able to arrest the captain of the commercial fishing boat and unroll a slave fishing operation resulting in freeing over 2,000 slaves and reuniting them with their families. And something that was particularly touching for me was hearing that when Martha and her team interviewed a number of the released slaves after the authorities had unrolled this operation, they were amazed that somebody would use a camera in the sky to go look for them. And in a sense, underscoring to them that somebody valued their lives. For their work, the reporters of the Associated Press won the Pulitzer Prize for public service, something we were happy to help them with. And I'll just close by saying that this is one of many ways in which we see that remote sensing can both help us see a better world and a more sustainable one. Thank you.
Thank you, Walter. On behalf of all of us at AGS, please know how much we appreciate the support that DigitalGlobe has given to us over a very long period of time.
Thank you.
Thank you.